Yeah, thank you. Thank you so much for giving us this opportunity to present the updates about this project. So a year ago, me and Huang presented the same project, but where that was at very initial stages where we were kind of evaluating different data repositories and trying to find out the framework which was best suitable for what we had at CMM at UQ. So Pitschi is the workflow we developed and which is in practice at the moment. So Pitschi stands for particle image depoT using storage caching infrastructure. Why we named it Pitschi, I'll explain it in one of the other slides. So first, I'll be talking about why we were motivated and what was the motivation to start this project and the objectives we plan to achieve. So then we'll present what Pitschi offers, followed by a small demo by Huang. And at the end, of course, discussions and questions are welcome. CMM. So I think most of you know us. It's UQ's microscopy, characterization, and microanalysis core facility. And it is also part of National Grid of Microscopy Australia facilities. So we do have a diverse range of instrument platforms, including electron microscope and microanalysis, X-ray diffraction, and imaging mass spectrometry. So these instruments have very simple to very complex configurations. Some of them generates huge amount of data per session, and that's where the complexity of challenges gets at its peak. So those are the things I really needed to highlight before we explain what Pitschi is. So and another thing is these instruments, the CMM instruments, are operates on 4 different sites at UQ St. Lucia. So, and you can imagine each building has different networking specifications and different issues to deal with. For example, one of the building has most advanced networking in terms of hardware, whereas the other one are kind of quite challenging in terms of data transfer. So in brief, I can say like CMM provides data management, analysis, and visualization expertise to support research projects, which requires the development of a central image data repository according to FAIR principles. So to start with, I think I would like to explain the data management protocols we had at CMM before Pitschi. So before Pitschi, we were managing all the data just on ad hoc basis. So what that means is we didn't have any common standards. So each building was operating and not managing data very differently. Some instrument managers were syncing data every fortnight and cleaning up the local data storage regularly, but the others one looking after all these aspects every year. So that was the struggle to find out these details at central as a central way. The other thing was there was no central workflow, and there was no standard there. There were no naming specific naming conventions. So for example, user A comes in and he named his folder ABC, and the other one comes in XYZ. And after 20 days, they forget the names. And when they come back, they can't find their data. Because basically what happens is the data basically was stored on the instrument RDN collections, which means the data was accessible by all the users who has access to that instrument. So it's a big folder that, and we had the lack of data security at that level. Just by mistake or by intention, if our data is lost or the file is moved or file is renamed, there were no proper tracking system. So that was another challenge. So for example, if a file is deleted by mistake and the person comes in after like 14 days and he needs his file, there's no way to find out where that file is moved or gone. The other thing was to track the instrument usage. So there was no proper record of who used the instrument when. And for example, if the instrument is damaged somehow and we are trying to find out what exactly has happened and who was the last person on the microscope. We were unable to find that. And that's where the first step of this Pitschi workflow was defined, to have some proper tracker system which can help us to keep the tracking system running and all these things. So yeah, and okay, so the objectives. So we defined the objectives for this project. So we were basically, it was very, we were basically trying to establish a central repository, and the aim was to promote FAIR principle, data principle, which is findable, accessible, interoperable, and reproducible data. Before the Pitschi basically started, so we used to have, as I mentioned, instrument-based collections, and anyone who have access to the data can access that, to the instrument can access that. So what we proposed and implemented is a project-centric approach, which means only one storage collection is offered per project, and only those relevant people who are the member of that project can access their data. So in these terms, the data security is now manageable. So the next thing was, we wanted to provide end-to-end process. So what does that mean is, a user comes in, he captures his data using the microscope, we transfer raw data from instrument to storage collection, and after dropping all the data into the storage collection, it should be automatically, that each file should be automatically indexed in the image repository so that it should be searchable at some later point. Now, we needed to have some base information about instruments and projects. So what we designed was, so we tried to sync all this workflow with our booking system. In our case, it is PPMS, which is now RIMS. So what it has is basically kind of, you know, it contains all the metadata related to instruments, the sessions booked, and the projects, and the users, of course. So Pitschi basically starts by syncing all these data, and then go to the next step. So you will be hearing these words PPMS and RIMS in this talk quite often. So I would just like to explain what exactly these are. So this is one booking system we are using. PPMS was a standalone system which CMM had for years, but now UQ has changed it. So basically UQ has offered the same booking system UQ-wide. So many facilities are now using it, and they named it RIMS. So these are, I mean, functionality-wise pretty much same. Then the purpose was to, once the data is stored in the collection and index, it should be able to process using some platforms such as CVL at UQ. The challenging thing was, the data was stored at different locations, but there were no records of metadata. The researchers, what really researchers were doing was putting the metadata details in their lab books, and those lab books are definitely, when in the need of time, you need to find, take so much time to find the exact thing which we are looking for. So the good point about Pitschi is we offered automated harvest of metadata. So the file is dropped in the storage collections, and then it automatically reads all the metadata and store it in Pitschi database. So at the later point, if you want to search something or view something, it will provide you the thumbnail of the thumbnail images of your data, and you can search any specific value, for example, pixel value, or the name of the file, or the format of the file, and it will search and show you all related files. So the most important thing was, we were aiming to have as simple as possible for users to deposit data, which is, in our case, we offered in two ways. So directly from instrument to the data storage, or we can also use web interface to do that. So we will explain these things later. Next, please. Okay, so a year ago, me and Hoang presented the details about the evaluation of different repositories. So we still have that document, and of course, if you need it, you can just contact us, we can provide it. We selected three main repositories, Metadata, iRoads, and Clouder. And then we according to the needs we had at CMM and the infrastructure we have at UQ, Clouder was the most suitable one, suitable framework for us. So, and the reason was it was powerful, it has powerful search engine. The architecture very simple and responsive, and it was very easy to start with. So yeah, we selected Clouder. A little more detail about the Clouder is it's open source data management from the National Center for Supercomputing Applications, NCSA. Like I mentioned, we selected it over a wide range of existing data management solutions. Just let us know if you need more details. We have complete document for the pros and cons of each of these data repositories. And I think the talk was recorded as well. So David can provide you that if you need it here. So the main features which were best suitable for us were powerful search engine search capabilities. So you can do the name-based search and metadata-based search, so which is quite impressive, I think. Then it has automated metadata extraction. It was extensible, so that the way it is implemented, encoded was you can add more functions and extend the functionalities according to your needs. And this is what we did at CMM. So Hoang basically added many more functions than the ones which were provided in the general framework. So and then the flexible data ingest as well. So this is where data and metadata are presented to the users. And yeah, so why we named Pitschi is, so you can see this Clouder is a cat. So Clouder means a group of cats. So now we decided to give our repository the name Pitschi, because it was a fictional cat from the children's book. So that's how we ended up with this name. So I think, next, please. Next slide. Yeah. So I think I can hand over to Hoang here, so he can explain the workflow and give us a demo how it works. Thank you, Hoang.
Yeah, so thank you, Rubbiya. So before going into details of Pitschi, I would like to briefly explain the how storage works at UQ. So we take the storage here like for granted, but I think it's quite different from the other institutes. So, and it provides some context behind how Pitschi works and the way that we designed it. So basically, the storage around UQ is centered around a system called RDM, which is short for Research Data Manager. So, so this is basically a centralized system for research storage provision. So basically, the users go to the RDM website and request for their research storage collection to be created with the details of the project, the collaborators, and other metadata such as the grant, ethics, and how much storage they need for a certain period of time. And when the request is approved, and then they can mount the RDM collection. So from now on, I just use the RDM and RDM collection or collection interchangeably. So then the RDM collection can then be mounted on the instrument. And then once the data are captured and stored in the RDM, thanks to the UQ data fabrics or Medici, the data can be accessible using various different platforms like HPC or virtual desktops or workstations. And then by RDM, DOIs can also be minted for publication purposes. Now I mentioned the word Medici. So this is the UQ data fabrics. So the idea behind Medici is that the data only appears in the high-speed storage when and where it is needed, and then the system is responsible for moving data between caches. So at UQ, the archival data and many of the computing resources are located in a remote data center about 20 kilometers away from the main campus. And there are multiple caches in the main campus, and they are big enough to hold active data. And importantly, the data can be accessed at different locations using different protocols and via different devices. And the system is responsible for recalling the data if it's not in a certain cache, and to flush the data if they're not active anymore. Okay, so with Pitschi, so as Rubbiya said, we build Pitschi on top of a data management system called Clouder, and the diagram on the left shows the data model in Clouder. So at the top of the hierarchy, there's spaces. So basically, in space, you can specify the permissions of the user permissions. So basically, who can do what under that space. And then under space, you have collections, which is the virtual groups of data sets and collections as well. And under dataset, you have real files and folder, and you can have an arbitrary hierarchy of file and folders under each dataset. Now in Pitschi, we map each space to a project in PPMS RIMS. And then each space has its own RDM collection for storing data. And each dataset corresponding to a top folder in the RDM storage. And the project RDMs are automatically mounted to Clouder when it is configured in the PPMS. So to do so, we added a new field in the project in the project profile, which is called a field called UQ RDM collection number. And then Pitschi would sync from PPMS to its database any project with a valid UQ collection number, and together with all the users in that project. So meaning that only users with the sync projects can log into Pitschi via AAF. And I will show you later the Pitschi interface. Now, in order to do that, we've modified the standard RIMS projects registration. So basically, users ask a few more questions regarding their storage. So basically, it's mainly related to the RDM to see whether they have an existing collection for the storage for their project. So they have. So if they have, then we can just create that tag in the project profile. Otherwise, we will ask them to create an RDM, or we can create an RDM on their behalf. And as soon as the RDM collection is approved, then Rubbiya or myself that added the RDM collection number to RIMS, and then the project is synced to Pitschi. And at the moment, this process is done manually, and I would love to automate this process. Now, so with data ingest, so basically, like Rubbiya said, Pitschi allows two ways for the data to be ingested. So the user can go to the website and upload the data. So this is suitable for small data sets. Now with a bigger data set, the data can be captured directly from the instrument computers and then uploaded to the project's RDM. So with this, we provide two methods. Either it can be a direct transfer, or it can be an indirect transfer depending on the configuration of the machine. And I will explain about the differences in a couple more slides. So regardless of the way that the data is ingested, the data will land into the project's RDM collection, and then the metadata will be extracted automatically. Now with the web upload, it's quite simple. You just go to the website and then go to the dataset and then upload the data. So the data are then stored in a temporary storage at first and then move to the corresponding collection later on. So with this one, it's suitable for small data sets, and it creates an extra step for the users. So that's why we provide a second method, a second way to ingest the data, which is the data can be captured into using the RDM directly from the instrument computer. So with this way, the RDM or the storage collection is mounted when the session starts. The data are first stored in the local hard drive, and then it will be synced periodically to the RDM collection. And Pitschi keeps track of every file that is transferred or synced to the project's RDM. Now, with this way, we separate into two stages. So the first one is when the data is imported into the storage collection. As soon as this stage is finished, the user can access the data for processing or visualization. So basically, the data can be consumed right after they import into the RDM. And then in the second stage, the files or folders are then ingested into the Pitschi database, so that the files can be indexed and then metadata can be extracted for search later on. Now, as I said, so basically there's two methods that we provide. So with the direct transfer from the camera machine to the RDM collection, so this is suitable for most of the configurations where, let's say, the RDM collection can be mounted into the camera computer. So this it works for a more modern OS like Windows 7, 10. And the other thing is we can modify the camera computer. So for the cases that we cannot, either because the OS is too old, for example, running XP, or the we cannot modify the camera computer, then we provide a indirect transfer method. So with this method, then we make use of a third-party computer. We call it the data transfer node, where the sync is happening in that data transfer node from the camera machine to the RDM. Now, so this is basically this diagram explains how the direct transfer works. So basically, we installed a program called Pitschi client in the camera computer together with tracker, and when the user logs in, so these Pitschi clients then coordinates the file transfer and register the files and datasets to an API, which is then used to ingest into cloud later on. Now, with the indirect transfer to RDM, as I said, we make use of a third-party computer called a data transfer machine or data transfer node. And then the data is pulled from the local network mount and then ingested into the project RDM. Now, this sequence diagram explains how the user actions and system actions in the direct transfer to RDM. So when the user gets into the machine, they need to log using the UQ username and password using tracker. And then when they log in, the system will check a couple of things. First, it will check if the booking exists. If the booking exists, then it will mount the RDM collection of that project to the camera computer. And then it will create a local folder, create a project folder in the local disk, and then create a shortcut on the desktop. And then during the acquisition, the user needs to drop the data into that to-day shortcut, which are then synced to the RDM. And when the session is finished, the user needs to log off from tracker, which then finish the syncing and dismount the RDM collection. So at this time, it finished the first stage, which is the data importing. So the first email is sent to the user saying that the data has been successfully imported into the RDM, and with different ways to access the data. later when the data ingested into the clouded or Pitschi database, the second email is sent to the users and with information of where the dataset are in Pitschi. Now with the indirect transfer to RDM, the process is quite similar, but instead of logging in using Tracker, which is a local program, they go into a website which is hosted in the data transfer node. So basically, they log in using AAF, and they need to start the experiment. As soon as the experiment is started, then the RDM collection is then mounted into the data transfer machine. And the dataset folder is then created in the local shared drive. And then during the process of data acquisition, the user needs to tell the acquisition software to save the output into that dataset folders. And when they stop the experiment, it will finish the syncing and then send the first email about the data have been imported into the RDM. And then when the data ingests into Pitschi, then it will send the second email confirming the success of the ingest. Now, so this is the first email. So basically, so this is confirming that the data has been imported from ARM200, which is one of the cryo-EM that we have here. And then there's multiple ways to access the data. So you can using so with Windows, you can just type this into the Internet File Explorer and then type the username, password, and you can access it from the workstation or laptop. And or you can go to CVL, for instance, when you can access the data there for processing. And with the second email, this is quite similar to the first one. Apart from the first link, which is Pitschi, that if you click on it, it would take you to the data set in Pitschi with metadata and a couple of more thumbnails for visual aid of browsing through the data sets. Now, so with the demo, so in the demo, I will show you three things. So the first thing is I will show you the cloud of the Pitschi interface, and I can show you how search can be done either using the item names or the metadata. And with the second part is I will show you how the data is captured from XL30, which is a TM that we have here. And for the third part, it's not a live demo, it is a screen recording because the two cryo-EMs are being used at the moment. So I'm going to use it for demo purposes. But so for this, please feel free to stop me anytime to ask questions during the demo. Is there any question? All right.
I guess you can proceed then.
Okay. So if you so this is the Pitschi interface. So yeah, at the moment it has about more than 23 terabyte and 165,000 files being indexed at and if you click on it, so if you click on this green screen, then it takes you to AAF so that you can log in. So if you click on these spaces, it will show you the projects or spaces that corresponding to the projects that you're part of in the RIMS booking systems. So let's say that if I click on this. So whatever the data sets that is being ingested into Pitschi, Pitschi would try a couple of things. It would try to get the thumbnails of the images, like you can see here. So it is quite nice because it serves as a visual aid if you browsing through the files. Obviously, it cannot create thumbnails for all the files, but it can create thumbnails for many of the file types that we have here, that we generate here at CMM. At the moment, there's no thumbnail for MRC file, for instance, but I'll work on it. And the other thing is, so for this, it generates some, it extracts the metadata of the files as well. So for example, like, so this, you can see that this metadata is extracted using OMTIF. So, and the nice thing about this is you can use this metadata to search for it later. Now, for example, so this, so let's go to another data set, for example. So this is the demo that I created for the screen recording. So so this is metadata of the data set, and you can see that the system is 300. So this is a small data set that I created from the ARM300, so one of the 2 cryo-EM that we have. So now let's go to the search. So let's say so one of the nice thing about Clouder is that it provides a very powerful search feature. So let's say that let's go to search. You can search based on the item of the data set or the files. So so that's yeah, and any but yeah, it's not just that, but you can search based on the metadata as well. So let's go back to the data set. And on here, I go to metadata search. Sorry, my computer is quite slow. So let's go back to the metadata, right? So for example, if I want to search for all the metadata that use, let's say a certain plunge freezer, then let's go here, and then I'll just copy and paste because I'm not so familiar with this. So basically, yeah, it shows you you can use the metadata field in the items to search for it as well. So for example, with this, basically it shows that I have basically I have 2 data sets that use this Leica EM GB2 as the plunge freezer for it. Okay, so do you have any question before I move on to the next next one, which is the data capture in the XL30?
That's okay, Hoang. We'll keep 10-15 minutes for questions at the end.
Okay, yeah. Well, I just figured that during this demo, it's if I go a bit too fast or any questions.
No one's screaming in the chat section, so I think they're fine.
Okay. So now the next one, I will show how the data can be captured from an instrument computer. So this is the direct transfer where the RDM can be mounted into the camera computer. So to do that, I just log into the computer. So this is the remote login that I have. So the machine is XL30, and before this session, I already made the booking for this machine for an hour for the purpose of the demo, right? So this is the tracker logs in. So this is present in all the computers with Pitschi in it, and the user need to log in using the UQ username and password. So when the user logs in, it does a couple of things. So so it will first mount a collection with this one that corresponding to the project, the CMM FOSIT Q3504. So this is the RDM corresponding to the project that I used to make the booking. And then it create a shortcut code today in the desktop. So and to save the data, basically I need to create a folder, which is let's say DL demo MA XL30, for instance, right? and then to save the user need to tell the acquisition software to output the data here. So because I'm not actually using the machine, so I just copy a couple of images that I prepared beforehand. So it's nothing serious. And what's happening in the background is that as soon as the user logs in, Pitschi will start a background process that it triggered every few minutes, and then it will copy the data in this today shortcut folder to the project's RDM. And then as soon as the user logs out, the RDM will be dismounted. Now it's the configuration, how often the sync process is done. It can be changed as part of the configuration. So okay, so so while waiting for the data to be synced, again, is any question?
I think it's all good, Hoang.
Okay, I've got one small one. Sorry, Sandy here from Deakin University. So we've got a lot of the same problems that you've got, the same issues with getting our data from the many different types of instruments that we have here and the different configurations of the computers attached to the instruments. So we've got the same issues with some of the instruments. It's just logged in with one generic account. You don't log off the computer, and others you log on there on the domain. So you log on with to the computer with your credentials, your local credentials. So if you are logging on, you're all on the same login, generic login. You log into your tracker.
Yes.
And that determines, based on your booking, that determines the project that you use, that you're
yes,
generating the data for.
Yep.
And that determines the folder that's going to be mapped. As far as logging off the tracker, sorry, I missed that. So the user has to log off the tracker at the end of their session.
Yes.
Otherwise, you have trouble.
Yes. So there's a couple of things, right? So this tracker is it will show the actual usage of the computer, of the instrument. So the user can leave it there, but I think they will learn that. Yes, they will learn their lesson after they they look at the views.
Yeah, but, okay. If they leave it, they'll be charged for the extra time.
Yes. So that's one of the things that that the users found it quite hard when we wrote this out. Yes. Because they didn't have that kind of a thing beforehand, right? Like they just go in there and then like use it and then walks off like after that.
If nobody else is waiting for it, that's fine.
And so that's why so we actually well, I explained it a bit later in the talk, but like we actually had to work with the instrument custodians and lab managers to have some sort of checklist, because that's quite important. And then the checklist is actually present next to the instrument, like what to do, and then you know, what happens if you go there and then like other users actually using it, that kind of thing. And then and so when we first rolled out, we did not charge any extra. Well, this is actually Rubbiya is handling all this, so I'm not quite sure. So we did not charge of any like extra apart from the bookings, but I think that will be the practice when this is when people get used to it. But I think so so far we get about like I think 17 or 18 instruments so far, and people are getting used to it. So
you charge by the hour for the booking of the instrument, and you just charge for what they've actually booked, not necessarily what they've used at this stage. If they go
Yeah, there are multiple settings of this tracker. So you
Yep.
can either charge just for the book session or the usage,
Yeah.
or you can adjust both of them. So
Yes.
at the moment for us, we are using adjusting
Yep.
the usage and the book sessions. Yeah.
Yep. Yep. We've got something similar. We use ACLS from University of New South Wales. We use that for our bookings, and they have the two different, the tracker and the yeah, similar.
Oh, yeah.
But
So
yeah,
sorry, what is system's called?
it's ACLS,
ACLS. Okay. Yep.
University of New South Wales.
Well, while talking, so there's a background process that syncs the data already in this in the folder or the RDM collection. So it's a small amount of data, so it doesn't it's just quite fast. Nothing about it. So as soon as the user logs off, I should receive an email confirming that that the folder is created. The folder, the data sets has been imported. Let me switch. So yeah, so before we have tracker, so basically anyone can just walk in and start using without if no one is present there, then they can just start using it. So yeah, so as soon as can you see my screen?
Yes.
So yeah, so right after I logs off, then an email is sent to my account saying that this data has been successfully imported, and then there's different ways to access the data. Now at this point, the data are not yet registered to Pitschi yet because it's not been ingested, but you can still access it. Let's say with CVL, right? If I go to CVL, then I can see the data there. So yeah, the main idea for this is so as soon as the data is imported, then people can just jump right into it to start processing instead of waiting for it to be ingested into Pitschi. And then so this is the collection that associated with that project. And so Excel 30, so 22, and then so yeah, this is just some of the images that I put in early on. And then after about an hour, then the background process then start ingesting the data into Pitschi, and then at that time you can visualize it later on. Okay, so that's how the data capture is done in the direct method. Now with the second one, like I said, because of the let me just go to full screen. Right, can you see this the screen I'm sharing now?
Yes.
Yeah. Okay. So like I said, this is just the screen captures, right? So this is from one of the two cryo-EM that we have here at CMM. So instead of logging into tracker program, in this one, the user goes from the camera machine. The user actually goes into a website that is hosted in the data transfer node, and they need to log in using AF. And then once they logged in, they can start the experiment, or they can, so this is, or they can visit the previous data set that they imported from here. And then with all the metadata that they presented, and it shows all the files in the data set. So to start the process, they just start the experiment. And so this is the data set that I created, that I just showed earlier. And all these metadata and the sample specific metadata are then ingested into Pitschi together with the data sets. So as soon as the experiment is started, there's a Pitschi will show the path of the data set, and basically you just go into that data set and tell the acquisition software, in this case CREM, because I don't know how to use CREM, so I just mimic it by just copy an existing folder over. And so in the background, there's process actually pull the data from this location to the project's project storage collection. So you can see that there's a green tick there, and as soon as there's a green tick, that you can list all the files that have been imported so far. And so for this, like to end the experiment, they just stop it, and they can delete. I can choose to delete source. And then again, like you can visit the history. So those all of the data sets that you have imported or ingested so far, with all the files.
I've got a question again, sorry.
Yep.
Just wondering, do you have different levels of access into this system? I know some of our laboratory managers like to be able to see all the data from the instruments that they manage, so that they can see that experiments are conducted correctly, and they just like to have that overview of the instruments that they manage. Is that something that's possible?
Yes, that's a very good question. Yes, so normally here at CMM, the lab managers are one of the person in the project. So
Okay,
they do have access to the data generated by the instrument. But then we also have a service account that that we can give to the lab managers, so that they could access to the data as well. But yeah, most of the cases, they don't even need that service account because they are part of the project anyway.
Yep. So they can drill down, they can see all those folders and drill down to everything that's relevant. Yep. Thank you.
Oops. I think I just decided to skip the videos, but let's go back to, sorry for this. So like same as before, as soon as the you get the first message, you can access the data using using CVL. So so this is thanks to Pitschi. So yeah, at UQ we take that for granted, but I think it's really convenient. And once the data has been ingested, then yeah, the main difference is that there's a Pitschi URL there, where it can take you to the URL, and when you sign in, then you are presented with the data that you just created earlier, and then all this metadata that you entered earlier, and the files, and if the files format are supported, then Pitschi can extract the metadata as well, so that you can search for it later on. Okay.
So you use AAF for authentication. If you had a visiting academic from another university using your instrument, would they be able to log into their own institution and use the system?
Well, this it is actually more complicated than that because
Yeah.
because the UQ RDM is a UQ specific thing. So
Yes.
most of the cases, we actually ask the visitors to create an UQ account.
Okay.
Yeah, but
Yeah,
that's
we have the same thing.
yeah.
If the clients has to use the instrument independently, they need to have the UQ username anyway. So if they have the UQ username, they can follow all this protocol.
And if they don't, then they're hosted by somebody who helps them. Yeah.
Yeah.
If
they ask P for service things, so for example, if they ask our staff to work for them, that's a different thing. That's where we have like specifically the RDMs and projects created for that, and only admins can use those ones.
In the interest of time, Hoang, could you maybe wrap up in the next 2-3 minutes so that then we can have like 2-3 minutes for questions, maybe?
Yeah, sorry for that.
Thanks.
So far we have we have Pitschi in the 18 instruments at CMM, and so far we've converted, or we put I think was that 50 something, almost 60 projects into Pitschi. So that covers about less than 10%. So of all the projects, of all the active projects. So there's still quite a lot of work for us. But the good thing is that many projects that using the two cryo-EMs are actually config and using Pitschi. So that's why that we have many of the data are coming lately. A lot of data coming lately are actually from the two cryo-EMs. And we do provide regular trainings, and that should be it will be part of the onboarding process for new users and projects. So just wrap up. So what we've done well, I think Clouder is the right choice for us. And the only regret is that I couldn't contribute to their version 2 development. We get some very positive feedbacks from some of the cryo-EM users. So I think we should have started with the instruments that generate lots of data, because those are the people that can benefit from this kind of work the most. And we've accommodated new requirements and changes quite well. And especially the latest change we got is we moved from PPMS to RIMS, which is a centralized system for bookings at UQ. But then we still need to improve in quite a few things. So we should have focused more on communication, communicating with users and communicating with ITS. We should have done it better. And the trainings are quite slow for various reasons. But we would like to think that we've ticked most of the objectives that we specified earlier. Because of the time, I'm going to go into details about it. But yeah, to get the project to this stage, it requires effort from quite many people. And these are the people that involved to help us set up various parts of Pitschi. And we would like to thank Chris Cloud, Medici, and the UQ IDM team. And this is an ARDC ACCS project. Yeah, well, feel free to give any questions to me and Rubbiya.
Thanks, Hoang, and that's okay. Thanks, Hoang and Rubbiya. We have time maybe for 1 or 2 quick questions. So Erin asked a question whether Pitschi is open source. So Rubbiya answered yes. Okay. Maybe I have a quick one about Pitschi in open source and Clouder. So if another university wanted to adopt something like Pitschi, another facility, would you think that they could adapt Pitschi to their university or to their facility, or would you think that they should just go with Clouder first? Or is Pitschi too tailored to UQ to be used anywhere else?
Well, Pitschi is a so we modify Pitschi so that it works with 2 EQ specific things, right? The first thing is the PPMS booking systems, but it can be modified so that it works with other booking systems like ACLS, as long as they provide an API. And the other thing is, because of Pitschi, we kind of take the data movement for granted. But it can be modified so that it can use another protocol to transfer the data. So yes, it can be modified to other institutes, but I think probably my recommendation could be they can have a look at Cloud first, and then yeah, and then Pitschi can be look at it after.
Thanks, Hoang. It's 3 p.m, so let's try to stick to the time.
Yeah.
Thank you, Hoang and Rubbiya, for a great talk. That was very interesting, and hopefully it's going to be rolled out across UQ now outside CMM. And that was a great talk, and thanks for everyone for attending. I've noticed there were many people from many places, and definitely from outside Microscopy Australia, so that's really, really great. Thank you, everyone.